Hello and welcome to this demo of the Red9 Studio Tools. My name is Mark Jackson. I've been writing this for a little while now. I want to take you through an overview of the current pack, which is 1.27, what you get for it, where it integrates into Maya, and some of the core functionality of it. We'll break down quite a few more of these into other videos over the next few weeks, hopefully anyway. So the first thing that you see is the Red9 in the menu. And these are all the main functions that you get in. So the animation toolkit, which we'll be going through in this video, there is an awful lot of functionality into this, including the post savers, the animation tools, etc. A simple snap, which is literally just a snap object A to B, something that's sorely missing in Maya. We have a search UI, which is for hunting down specific nodes within scenes and finding nodes within scenes for nodes of type. This will be going through in detail when we go through this filter hierarchy here. These are basically the same function, except this one in the animation toolkit is locked to transforms, whereas this one in the node searcher is a scene based search. You can search anything within scenes. We've got a lock channels, which is very useful for riggers. It stores out something called an atom map, and the attribute map is basically a file that stores all of the channel box status of every single node in the rig. So if we select the root of a node, it will store every single channel box status of every single node into a file. And you can also serialize that to a node itself, so you can store that data actually on this root node itself. And it's really great because what it means is that we can store the current state of everything. When we want to debug a rig, we can unlock every single channel, do what we need to, and then just literally load that map back, and it ensures that all the channel states are all exactly the same as they were, which is really good for animators and making sure that they've got the right channels. There's a metanode UI, which is something that we'll be going through when we go through all the metadata and how to add metadata to rigs. This is basically a debug for processing metadata nodes. There's a scene review, which is something that's kind of come across for studios more than anything. It's a way of tagging data inside a scene. We've got an active live review. That basically makes a scene node in the a script node in the scene. So when you open the file itself, this pops up and tells you exactly what's going on in the scene. This will go through probably a little bit more detail. We've got mouse mocap, which is a way of recording the actual data in your mouse to an animated channel. Key randomizer, we'll go through that again separately. This is just another function for randomizing animation data. There's also the animation binder. This is what I did for the live animation binding in 2011, the masterclass at SIGGRAPH. This is integrated into here. Then there's a few other places that the Red9 hooks in. First one is in the file menu. We've got Red9 Open Scene folder. This is OS independent, so it's been written to work on Linux and Mac as well as Windows. So we've got a file that's open from free rigs, Morpheus rig packs, Morpheus rig sit. If I go file, Red9 Open Scene folder, there's the file just there, and it pops it open for you, which is quite a handy little tool to have. If we go to the graph editor, this thing that we had up here, which is the randomized keyframes, that's actually integrated into the graph editor. So we go into the curve menu in the graph editor, we have Red9 add noise, and if we go to the box, that brings the menu up. If we don't use the box, it uses whatever the current op files are for that. Again, that's something we'll go through at a later date. And then finally in the script editor, this is a really handy one for TDs out there. If we select something and scroll through, that'll do. If you want to debug where any of these functions are actually coming from, for example, let's select that. If I right click, you'll see this R9 inspect function. And what that's going to do is that's going to open up the actual source of that function, where that function call is. So there it is, update auto, I think it was that one, isn't it, that I selected. So that's the function. This will open up that file in whatever is the current editor that's defined to open up mail files. So this is the Windows or Unix. This is whatever is the default for opening that up. Now it also does Python. One thing with the Python to note is that if you've got Python installed and you run a py file, it'll run it in the default Python, which obviously doesn't open an editor up. In my case, I've got it open just to show you here, and it'll debug it, and again it'll open up in UltraEdit, and there's the code that I'm running inside there. Maybe in the future I'll have it so it'll look if you've got Wing or maybe PyCharm or UltraEdit, Eclipse open, it'll find those and open it in there. I've not quite done that yet. Okay, so let's go to the animation toolkit and we'll go through the basic functionality of this. The main thing on all of this animation system is that this hierarchy controls everything that we do. This is how we tailor the data to work with your particular rig. Now we've got Morpheus in the scene here, and there's a preset for Morpheus down here. I'm going to go through this separately. The reason for that is there is an awful lot of hidden functionality within this, and it's a really powerful way of defining exactly how it uses your rig. It's the hooks that goes away and finds what your controls are, how it finds them, and how we process them. And the way of checking whether this is correct, if we select the root of the character and we go process filter, lo and behold, it'll find all the controls inside Morpheus and it'll select them. This is quite a handy little button here. By default, when you're doing animation functions, really you don't want to be dealing with this main world controller. That's normally just for moving the data around, and then everything else is dealt with inside that. So if we have include roots on and we do the test, that's left selected. If we have include roots off, which is how we're going to run the demo, that's left alone. Okay, so like I say, we'll go through that separately because it's quite a big deal. So let's go through some of the functionality. I'm going to select the root world space of him and the root world space of this rig, and we'll go through these top few functionalities. So copy attributes, and there's a hierarchy flag again. That's running everything inside here, so this has to be right. For most rigs, default will do because it's basically just a NURBS curve, but like I say, we'll go through that later date. So hierarchy. If hierarchy is off, copy attributes runs on selected pairs, so you can select object 1 will snap to object 2, object 3 will snap to object 4, and etc, etc. So the copy functions work like that, the copy keys functions work like that, the snap transforms do the same thing. If we have hierarchy on, obviously it is processing the entire hierarchy, so I'm going to copy all the attributes of this guy onto this guy here. Copy. Now you have to bear in mind this laptop is quite slow. It is a lot faster. Also, Morpheus has an awful lot of those in the rig, and I'll show you a way of speeding this up in a minute. But as you can see, it's copied that pose across, and it's basically that's copying all the attributes that are current on that node. Sorry, on this rig. Copy to many, which both copy keys and copy atta, which both of these have. In fact, let's just close. No, I've got it down. Which both of these have enables you to copy the data from this onto multiple rigs. So if we have 4 or 5 copies of this rig in, if you're doing a crowd scene, you can copy his walk cycle, his animation, A to B, and we just keep selecting other rigs, and that too many will copy that data onto all subsequently selected rigs, and same with the copy keys. And we've also got channel box there, which is fairly self-explanatory. Copy all the data from particular channel box attributes. Let's do the same thing for copy keys. So again, copy keys, if you've got 2 nodes selected, it will copy from A to B. If you've got 4 nodes selected, it will copy from A to B and from C to D. And we're going to do it on the rig, so I'll select the 2 rig nodes. Now, if the time range isn't selected, if that checkbox isn't on, what it's going to do is copy all the animation curves as it finds them from him to him. If time range is on, and you'll notice time range is in quite a few of these functions, by default it will copy the current editable time range that Maya's got. But if you wanted to take a section of this, let's say we want to just copy this sit section of him, what I can do is I can select in the timeline, and it will use this as its range. So I can go copy keys over that range, and it will do just that. Here we go, over that range. I'm going to undo that function because I don't want that copy data into there for the next piece. In fact, I'm going to do the copy as well. Not done. Okay. So next one, snap transforms. I showed you earlier on we've got a simple snap here. This one is basically intended to be dropped onto a shelf and used just as a simple snap. This is a much more complicated version of it. As I was saying with the rest of them, you can snap object A to object B. In fact, let's just do that over a couple of pairs, just to show that. So I'm going to snap these 2 wrists together, and I'm going to snap these 2 wrists together. So I've got 4 objects selected, snap, there we go. Obviously, there's a lot of stretching in there, but you get the idea. We'll undo that. And that is over range as well, so we can do that over range, so we can say actually no, snap those objects together over that range there. Snap. If it runs. and it processes those over time, and we'll do that. Okay, and we're going to do the hierarchy. Now for this I'm going to use the selection sets that Morpheus comes with, and the reason for that is that, as I say, Morpheus is a very big rig. There's all sorts of hidden stuff inside here, and for the snap we don't want to be snapping things that we don't really want to be processing. So I'm going to use 2 selection sets. Gives us all. Now with the selection sets, this hierarchy treats the selection set effectively as the top of a hierarchy, and it selects all nodes underneath that set and runs with them. And it's the same with character sets, it will deal with character sets as well. So, hierarchy. Now we've got 2 options here, pre-copy keys and pre-copy attributes. This snaps data, and it snaps it in world space. Now obviously if we're taking rig data between these 2 rigs, there's an awful lot of other attributes that you might want to take. So this pre-copies the keys and pre-copies the attributes to make sure that you get all those extra custom attributes across. One thing you can do, which is quite handy, is you can use it for doping out animations. So let's say we've got this animation here and we want to get the gist of this animation. This is actually mocap. Say every 10th frame from him onto this guy here. I'll select the 2. I've got these 2 copies off, and the reason for that is I don't want all the extra keys going over. I just literally want to get the bulk of the data across. So I'm just going to do in between, say, let's find something that makes sense. Here we go. Let's take that data over from there to there. So it's going to do a snap in world space between these 2 rigs on every 10th frame. Okay, so as we go through, you can see he goes through. And he's kind of got the bulk of the animation. That's every 10th frame snapped across. And obviously if we take that off and we do it on single frames and we put these 2 on, what you've effectively taken is you've taken the data from this first rig over to the second rig in world space, ignoring any extra root transforms, and taking that data across. Which, as I say, is quite a handy thing to do. Ignore the clock. Right, I'm going to turn this first guy off because we don't want 2 rigs in the sync. Let's try and speed this machine up. Take him off. And let's move on to this track and stabilize. Track and stabilize, as the name suggests, is 2 functions rolled in one, and it determines which one it uses based on how many objects you've got selected. If you've got 1 object selected, it'll try and stabilize that node. If you've got 2 objects selected, it'll try and track with an offset. So let's do the first one, which is stabilized. Now this is a bit of mocap, and one of the things that always happens with mocap is that feet always twitch. You always get a bit of noise in foot data, or if he's trying to if he's actually making contact with points in space, there's normally a bit of motion. Actually, that's not too bad. Let's go through and find something that's a bit worse. There you go. That was quite bad. That one there. Okay. Let's zoom into that a little bit. And you'll see as his foot lands, bang, it slips quite badly and there's a bit of noise going on. So let's say we just want to get rid of that really quickly. Here's the frame I want to start with. I'll select that node there. I'm just going to hit the button a few times, and basically the reason for that is it shows you live update of what it's actually doing if you keep hitting it, and you can normally pretty much judge where you want to come out. There we go, that's locked it in place. Now that's not deleting keys, that's actually doing a world space calculation to try and figure out how to lock that node down. And we'll do it on this one as well, just to show you how fast it is. So we'll go, there's a bit of noise in there, wobbles, and we'll lock it to about that frame there. So we'll take it from there. And like the rest of the time range functions, I'm going to select the time range on, process. There we go, foot's now solid as a rock locked down. Now that will also run backwards, so if this is -1, you can do the time range, you can select it from backwards and it will run backwards as well. So if you know the point at which it's got to get to, you can run it backwards through the scene. Let's use this to track now. So we're going to have 2 objects selected, which then goes into the tracker mode. I'm going to put this ball into this guy's hand. Let's say from about there, shall we? We'll lock the hand into place. Sorry, we'll get the ball into place first. So we're going to snap the ball into place. We'll select the hand, select the ball, take all that off, and we're just going to use it as a simple snap, if it goes into the right place. ish anyway, so it's snapped to the wrist controller. So shift it so it makes sense that it's in his hand. You have to be accurate. I'm kind of messing around, that'll do. So we'll say from that point on, I want that ball locked into his hand. Now this isn't doing any constraints, again this is doing a snap calculation to get it into place. And I'm going to do it over time, so we're going to go from frame 62, we'll take it all the way up to, I don't know, somewhere around there. Process. Done. So from 62, there it goes, the ball is nice and solid in his hand. This also works on component level, so if you go into multi-mode on your select, you can select a poly mesh, or a face on a poly mesh rather, and you can pin down to component level using that, which is quite handy. Okay, so let's get that other guy back in. I want to show you the time offsets. Where is he, that one there? Got it on. 2. Okay. This guy's got no animation on, so let's just push a bit of data onto him so you can see what's going on. So I'm going to copy his animation onto this guy's animation. Let's do the whole thing. Copy time range, copy keys. Okay, so they've both got the same animation data on. So the time offset has got a few different modes. With all of the buttons off, sorry, with all the checkboxes off, it's an object selected mode. So if I select a single node, this will offset the animation data for that particular node only. If we've got hierarchy, it's going from the root, filtering the hierarchies, and then offsetting the hierarchies, and that's great because, excuse me, if you've got a crowd scene, etc., I can say actually I want to delay this guy by 10 frames, and I'm just delaying that, so I'm using the hierarchy, delay, and he's now 10 frames lag on the other guy. I'll just show that because when he sits down there, there's a bit of lag in it. If we go full scene, in full scene this becomes available, this offset timelines. So if I want to offset the entire scene by 10 frames, I can do so. You see they both pop. If I go offset timelines as well, you'll see no difference whatsoever. You notice we're on 158, frame 158 at the moment. If this offset timelines is on, it's going to offset all of the timelines, including the current frame. So you see the timelines popped. Let's now jump to 168. The characters are still exactly where they are, but it's shifted everything across. So that's quite handy. The randomizer and flocker really are for, they're not really for character animation data, they're more for dealing with walls or breaking fences, or there's a demo that I did earlier about this. We might go back through that, I don't know. Now the mirror controls, I'm going to do that as a separate demo. The reason for that is that to get this to work you actually need to put some extra data on the rig. You need to put the, what I call a mirror index, the mirror side and the mirror axis on, so you need to actually tell each controller what its matching pair is on the opposite side, so left to right, etc. And we'll go through that probably when we go through metadata and how to wire a rig into metadata. But for the time being that won't work unless those attributes are on the nodes. So I'm going to get rid of this second guy again. In fact, we'll delete him out of the scene because we don't need him anymore. Okay, and what I'm going to do is, oops, excuse me, is I'm going to select the selection set that we did earlier. QSS, in fact, no wonder it's slow, I've still got echo on. Turn that off, take that off. Okay, pose. So we're going to go to the pose manager. Now the pose manager, again, the hierarchy and what the pose manager saves is controlled by this. So this really is the crux of all of this animation kit. And you notice we've got a few things. We've got a pose path, which is the folder in which the animation, the poses are actually stored in and where it's going to save the poses. We've got two modes here. We've got local and project poses. The definition between these two is that really the project poses are aimed at studios. So for example, a local pose is something that's stored on your machine to this path. You have full control, you can delete, you can overwrite, you can update. If we switch to project path, you'll notice that the save scene button disables. The delete button, rename and update buttons all disable themselves. So these are really, this would be effectively a network drive, let's say, where your lead animator or whoever's controlling would say these are your master poses for a system. And everybody else uses those as reference and can load them, but that's all they can do. So go back to local poses. there's quite a few things bound onto the right button click. So if we select a pose and we right button, we've got delete pose, that's fairly obvious, rename pose, update pose if there's a pose here and we just want to tweak it slightly. There's two debug options, so we can open the pose file, which will do just that, open the data that's inside that pose. We can open a pose directory, which opens the directory containing that pose. There they are. This one's quite useful, copy pose to project poses. So as we were saying, if we're in project pose, the save is disabled. You can't actually save a pose in that mode. But what you can do is you can save it in local pose, and then you can right click, copy pose to project poses, and it will copy that into the project folder for you. Again, it's just a way of managing data. We can also switch the UI to thumbnail view or to text view. And in thumbnail view, we can change the size of the thumbnails. That's fairly fairly standard stuff. And also, obviously, as you move the UI, see how slow my laptop is. If you move that across, the grid updates itself. Okay, so let's load some of these things. So the first thing we need to do is we need to give it a route. So we've got select route, and all I'm going to do is I'm going to give it a quick selection set, just so it's a slightly less data it's processing as it's going through this. And we can select a pose, we can go hierarchy, let the pose. And we've got quite a few poses stored in here already. Sit pose, etc. You notice there's a hierarchy flag here, so by default it's processing the entire hierarchy and saving and matching those poses off. If we take hierarchy off, we can load the pose onto selected nodes only. So we'll just, let's say, select the wrists, excuse me, select the wrists, and we'll load the data from that pose onto the wrists. Got the pose we've already got? Yes, it is. So we can load it onto the selected nodes. One of the really useful things about this is this has relative poses. Now let's say you've got a walk cycle. In fact, we have got a walk cycle on this guy, haven't we? So if we he starts somewhere around here. If we get to walk left leg, let's say, for example. So he starts over here, load the pose. That's where the pose was actually stored out. But he's going to walk cycle. What if you wanted that pose and you want it here? If I load it, he's going to pop back because poses are saved in world space. They're saved as the data inside the rig is actually is at that point. Well, what the relative mode does is it allows you to offset that data. So I can come back here and I can say, actually, I want that pose loaded as if that foot were locked in place. So basically, I'm going to load that pose. The pose will load somewhere in this space, somewhere around where the ball is. And it's going to do a difference between where that controller is in the pose that it's loaded and where it currently is, and it's going to shift the entire pose back to match. So if I keep his foot selected, relative pose, load it, and the rig explodes. Cool. How useful is that? Where are we? Morpheus. Include. Load pose. Excuse me for being a cretin. What have I done wrong? Start again. Load pose. That. Relative pose. That pose there. Oh, it's because we've got quick selection set selected, that's why. Okay. Let's do it off the actual selected node. The reason it's going wrong, and again this is something I need to go through with this when we go through it, is this here. Filter node priorities. Morpheus has a lot of hidden controllers for controlling bendy, etc., which aren't actually in this quick selection set. What it's doing is it loads the pose, and then for the nodes it gets back from that filter, it snaps them. Now, obviously, there's a certain order in which sometimes you have to snap things, and if that order is wrong, you end up with that crazy result that we just had. If I use it with the root of that, so I'm going to give it the root node, not the quick selection set, which is everything inside the rig, which means everything is going to get processed, and we'll try that again. Okay, so we'll select the node, load pose. It's taking an awful lot longer to load. There we go, and it'll load it back from where it was. So let's just do that again. Relative off, load the pose, which means the pose is over here. Notice where his foot is in that pose, so it's up there. I'm going to jog back to back here somewhere, which means this foot is effectively going to be locked in place. Obviously the rotates of the pose are going to come from where the pose file was, so this foot is going to rotate up, but he's going to be loaded as if he were around this position here. There we go, done. Now there's a few other bits on this that we need to notice. We've got this here, projected and absolute. Now, this basically is projected is the ground plane, or what it perceives as the current ground plane. So rotations are basically the direction he's traveling in, based on the ground plane. Translate method is the ground plane itself, so everything is, in this case, everything is X and Z. There's no Y translates allowed when it does the offsets. So let's say we have this foot and we want to load that walk pose, but he's actually going up a step, or he's moved up a step. What I can do is I can select the foot controller, shift it up. I'm going to say translate absolute, which means that it's the absolute value, which means it's going to respect that translate that I've just put in. Maybe shift him up as it's doing it. In fact, let's do it up and we'll roll him around a little bit, let's say. And it puts them in place. So that's quite a handy thing for poses. It's something I've not seen in many. And then we've got this thing called pose point cloud. Now, pose point cloud is kind of hard to describe. It's the system that internally the pose saver is using to do the offsets. Remember I was saying it snaps data back? Well, what it does is it makes a cloud of that data, and then it moves that data back and then re-snaps the cloud. And visually you can see that by making this pose point cloud. So what I'm going to do is I'm going to select something that I want to be the pivot point for the point cloud, which is effectively where the parent of the point cloud is going to be, and I'm going to go make point cloud. And what it's done is you can see it's got a copy of the geometry. It's made a ton of locators for every single controller it's found inside Morpheus, and there are an awful lot, so you can see the hair, points, etc. But what it does is it gives you this piece of data, which I can say, actually, no, I want that pose there, over there, let's say, I want the pose there. Okay, so I'm going to go snap pose. And you'll notice that pose updates and matches where this thing is. I can update the data inside there, so if we say he's now sitting down, I'm going to update the pose point cloud. Notice that the mesh updates itself as well. And then I can just go, actually, no, I want that sit to be just there. Sit. And then I'm going to delete the pose point cloud afterwards. Now you notice we had a geometry reference there. In this particular copy of Morpheus, I've wired up from this node, I've wired a thing called render meshes, so it's got an attribute called render meshes, which is wired up to the mesh of this character. Obviously, if you haven't got that, what it can do is the second node you select, so if you select a point and then you select the mesh, that second node, the mesh will be used as the point cloud reference. And then lastly, we've got in here, we've got a search filter. So this is quite a handy little thing. In 2013, it's live, so as you type, it does it. In 2012 and 2011, you actually have to hit return as you're doing it. So I'm all walk poses. Return. There's the walks. Like I say, if you're in 2013, as you're typing, that's live. If you're in 2012, you have to hit return because the functionality isn't there. I hope that's kind of given you a rough idea of the pose. As I say, the frightening thing is when the character all goes wrong, and that is all to do with the order in which these filter priorities are set. And basically, as I say, it's a snap. So if you can imagine, you snap the root of the character in place first, and then you snap the hips in place. If you were to do the opposite way around, you snap the hips first and then the root, you'll get double transforms, which is what we were getting there. Okay, we'll do some more videos in a bit. Hope that's helped. Bye.